Hello.
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 Okay. Should see the desktop now. You should be able to hear me okay. Um, let's see. Almost ready. Okay. People are still coming in. Still a few more to come in. Okay. All right. We'll wait another few seconds. Okay. All right. So to start, let me remind you that there'll be a test. It'll be a week from today. Okay. So the test will be a week from today. Okay. So first, does anybody have any question about the homework assignment? Okay.
I know you said that you were thinking about changing the due date. Is it going to remain Monday?
I think so, because I think it's important to do this assignment because it really it's a good way to prepare for the exam. So yeah, I think I'll keep the due date on Monday, okay, and use it as a way to yeah. If you have questions about this homework assignment, those are good questions to ask about the whole material and get ready for the exam. So I'll leave the due date on Monday. So right now the homework assignments due the 28th, and then the exam is on. So homework's on Monday and the exam's on Wednesday. Okay.
Could I ask a question about the homework?
Sure.
So I'm writing it right now, and I got it to where, I got the order and everything, but I'm kind of struggling on the capitalizing it.
Um, you want to you have to use the two uppercase method.
Okay.
Yeah, because it's the only way you have of changing something from lowercase to uppercase. But you can't two uppercase the whole word. So you
Right.
have to use substring to get the first letter by itself. So use substring to break off the first letter by itself. Then that letter is a string. Then you can two string it. You can two uppercase it, and then you can put things back together again. Okay.
So I can use substring to like give a variable for one letter,
Yes.
and then I just capitalize that
Yeah.
variable.
And then add it back on to put it at the front of the word.
Right.
Yeah. So that's the trick. You don't you have to break it apart, make a change, in this case uppercase it, and then put it back together again.
Okay. Thank you.
Mm-hmm. Okay. What about other questions from the homework assignment? Anybody else have another a question about ideas for the homework assignment?
Yeah, wait, hold on. So, this is just like one code, right? Like we're not writing like different ones for each input, right?
Yes. No,
It
you're
should work
writing.
for all of them.
Well, you're writing a program that'll work for any input somebody gives it.
Okay.
So
Yeah.
the program doesn't have the input in it. The program prompts the user for the input. So the
Right.
program has to be ready for any possible input.
Right. Because I saw like the spaces with everything. Like
Yeah,
all of this should still work with the same one, right?
sure. Yeah, like these examples here. These
Right.
are specific examples, but your program should work with any example. Yeah. In the homework assignment, I gave you some examples, but I could test it with as many examples as I want. Okay. So these are not the only examples you have to worry about. You know, your your program should solve the problem described here. So this describes a problem. It doesn't say what the input is. It gives you examples of input, but those are just to help you test your program. They're not saying your program works only for these inputs. Okay.
Right.
So I give you a couple examples here. I give you a couple more examples here, but your program has to be ready for any possible input. No
Okay.
matter what somebody types, you have to. Your program should work with it. Now, I think the only thing you don't have to worry about is here. You don't have to worry about this problem. You don't have to worry about somebody typing space, 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 hello there. Okay, you don't have to worry about there being spaces before the first word. So the first word begins in the left-hand column. Okay, that's the only thing you don't have to worry about. Okay, because that would have made things kind of messy. So I decided that you could just assume that the first word is right at the beginning of the string. Okay, anything other than that, you have to be ready to handle. Okay. Okay. What about other questions about the strategy or ideas from the homework assignment?
How do you get to that page that had like all the methods, like the 2 uppercase and everything?
Download the zip file. It's in the zip
Yeah.
file.
Okay. All right.
Yeah.
Thank you.
Yeah, one page. There's 2 actual for the string. This one's the more complete one, but I also put another one in there that's smaller, but maybe people might find it useful also. So there's 2 little tables about the string, and then there's also a table to help you remember what's in the scanner. There's a table of what methods you can use inside of a scanner and a little bit about each one of them. Okay, so they're in the zip file. I couldn't find nice tables like this on the internet. And these were stolen from a book. I scanned a page from a book. I haven't found there are complete summaries of the string class. If you go to the internet, you get complete description of the string class, but that's too much. This is pages and pages and pages long. Yeah, there's just pages and pages. Yeah, the whole thing, I forget how many pages it is. This is everything in the string class. And we're not interested in everything in the string class. So a nice summary of what's mostly useful in the string class. I haven't found a nice web page that looks like that, but this is a good example of a summary of what's really useful in the string class. This is what you need for the homework assignment. So I stuck it in the zip file because I couldn't find it as a page on the internet. Okay, all right. Anybody else? Any other question?
Is there a spot to submit this?
Pardon me?
Is there a place to submit this?
Oh, is there? I probably forgot to create one. There isn't one, is there?
I don't think so.
Okay, then I forgot to create it. Yeah, so I have to, after class, send me an email to remind me. I have to create the submission thing, the tool on Brightspace. Yeah, that I have to create that, and I forgot to do that step. So that should be up there later this afternoon. Okay, send me an email, remind me, because I might forget again. Okay, so I'll create the tool for submitting it on Brightspace. Okay, any other questions or comments? Okay, so next thing, anybody got any questions about these review problems so far? Anybody had time to look at them or have any questions about these so far? Any questions yet? Remember I said that these are review problems. They're not the test. You can ask questions about them. You can talk to people about them. You can use the books to look them up while you're solving them. The important thing is to practice with these. Make sure that these you're comfortable with these kinds of problems. Okay, right? So anybody anybody got a question? Anybody had a chance to look at these and come up with something that they're wondering about yet? Anything? Okay. Okay. So same on Monday. If you have questions, if anybody's got some questions about these problems on Monday, we can try some of them on Monday. And if you have questions, you can write to me. Okay. All right. So the next thing, see, we remind you about the exam, remind you about the homework assignment. Okay. The next thing is the reading assignment. Okay. So we're going to start talking about a new topic. These conditionals and if statements. Okay, so we're going to simultaneously work from both books to start with. Okay, because this one book has kind of a terse overview of the ideas. It's not, it doesn't explain, it explains the bare bones of what you need to know. It doesn't give a lot of examples, but it does state everything. So it's a real good summary. This chapter, here are the sections in it. It's a real good overview of what we need to know. Now, the other book has got more details and includes a lot more problems for you to think about. So at the same time as we're talking about this one, we'll also start talking about this other one. Okay, they both pretty much start off talking about the same thing. Okay, they notice that this one starts off with equality, and this one starts off with equality. You know, they say things in pretty much the same order. You know, they cover the ideas in the same order. Though this other book tends to have more detail, and this book tends to be a more of like a summary. Okay, so here's what we want to do. We're interested in letting programs decide things, to make decisions about things. Or another way to put it, a program should be able to ask a question and then make a decision based on the answer. Okay, you know, in games, you might need to know, did the character turn right or did the character turn left? Did the character pick something up or not pick something up? You know, if you're doing an online ordering system, you have to ask if a customer is over 21 or under 21. You always have to be asking questions and checking things. So that's what we call conditionals and logic. Conditionals are the things that ask a question. Another word for them is Booleans. Okay, so this is a real simple example of asking a question. It's really asking, is X equal to Y? Okay, now let me show you something real quick. There's something that's a little bit tricky here that the book never mentions that's really worth talking about real quickly. We have this. Now we're going to do this. And those are two very different things. Okay, so notice that what we're doing over here, this was from way back when. You know, we started this almost the first day of the class. Now we're doing this. Okay, so now we're doing this equal to operator. And you have to keep these straight. If you're in a calculus class or an algebra class, you might see somebody write m equals 3, b equal 5, y equal mx plus b, something like that. Okay, these equals here are this one. Okay, then somebody might in a math class write the following. Okay, that's asking for which input x is the line equal to 0. So you're asking, where does the line cross the x-axis? This x, this equal sign, is this one. Okay, if in a math class we use the same equal sign to mean two different things, but in programming we have two different equal signs. This one we call assignment. It's saying x should get whatever's in y. I'm assigning to x whatever value's in y. It's a lot easier to think of it as you think of it like this. That's saying put 5 in x. If you do this, you're saying, well, whatever's in y, put it in x. This is asking a question. And the answer is okay. Notice that this is a true-false statement. It's either true that x is equal to y or it's false. This is not a true-false statement. This is saying put whatever number's in y, copy it into x. So this copies 3 into m, copies 5 into b. Then it lets y be a name for that formula, mx plus b. But you know, in that we said earlier that these kinds of variables x and y are not programming variables. X represents all the numbers on the number line, and Y represents all the lines on all the numbers on the vertical axis. So X is all the numbers on the horizontal axis, Y is the numbers on the vertical axis. Then this asks, where does the line cross the X axis? What's the input to this formula that gives you out 0 so that the line crosses the axis? Notice it asks a question, okay? Like this thing asks a question. Yeah. Is X equal to Y? It's asking a question. Okay, that's a conditional. It's asking, a conditional is another way of saying, we have a bunch of different words, conditional, Boolean, or just think you're asking, you want to know, is it true or false that X and Y are the same? Here you want to find which X, you want to ask which is the X that makes this thing true? Which is the X that makes Y 0? Okay, now in math, we don't write, it would be much better if math wrote that, because this is a very different kind of formula than these three up here. And it's actually a real source of confusion. When students think math is hard, one of the causes of it is the fact that we're very ambiguous in what we write. This shouldn't be the same symbol as this, because they don't mean the same thing. Programmers learned that a long time ago. They need a separate symbol for that and a separate symbol for asking. So this is assignment. You're letting M be a name. You're letting 3 be the value of M. This is assignment. Okay. This is another assignment. Y is a name for that formula. So those are all assignments, but this one is an ask. Which X makes the output of the formula 0? So you have to solve for that. It's asking you to find the X. Okay, so here you're just asking, is it true or false? But you're asking a question here. Okay, so we're going to start talking about this other kind of, this thing here, this asking a question. Now, all of these ask questions. Is X, go back over to here. These are what we call the relational operators. They ask about a relationship between two numbers. Are the two numbers the same? This just asks the opposite question. Are the two numbers different? Is the left number strictly larger than the right number? Is the left number strictly smaller? Is the left number larger or equal to the right number? Is the left number smaller or equal to the right number? So every one of these has got an answer where it's either true or false. And now they don't do any code examples in here, but if we open up the Java visualizer, we can just type a little bit of code and see how Java does these. So let me say I have an int X equal, say, 12, and I have an int Y equal, say, 25. Okay, and I can ask, well, I'll ask a question, I'll print my answer. Okay, I'll ask a question in here so that I can see the answer. So is X equal to Y? Whoops, sorry. Equal. Okay, all right. Well, this is going to give me, the answer here is no, they're not equal. So this is going to be, this thing is false. So it's going to print false. Okay, see, it printed false. So this thing we say evaluates to false because we know that X equal to Y is not true. So it's false. Okay. On the other hand, if I go back and do something like make this okay, yeah, 6 plus 6. Well, 6 plus 6 evaluates to 12. So now the 6 plus 6 is really 12. So now X and Y hold the same number. So this thing is true. So this evaluates to true. Okay. And then I can do other examples. I can ask, I can ask, is X less than or equal to Y? Okay. In that case, yeah, 12 is less than or equal to 25. So I can ask any one of these questions in code, and the answer is going to be a Boolean. We really want to, now printing true and false is not very useful. So we don't want these things to print out trues and falses. We want to see in a minute what we really do with them. But this gives us a way to ask if how things compare. And we don't have to do this only with numbers. Let me just give you another example. Suppose I have a string S1 equals hello, and a string S2 equal goodbye. Now notice I'm using the single equal sign here because I'm doing assignments. Here I'm using the single equal sign, which says this one's a name for that, and this one's a name for that, okay? And I'm using strings, so I want to go down here and tell the visualizer to show me the strings the right way. If I'm going to use strings, I want it to draw pictures using strings the right way. Now I could ask questions about S1 and S2. I can say, for example, is the length of S1 less than the length of S2? Okay, so I can combine what you've been doing in your homework assignment using methods on strings. And now I'm asking kind of an interesting question. Is S1 a shorter string than S2? Okay. Now I go up here and I see that S1 has 5 letters, S2 has 7 letters. So yeah, I clearly can see that S1 is shorter. So here's a way where the program can ask a question. Which string is, which is the shorter string? Okay. So if I visualize this thing is going to, okay, there's my variable S1 pointing at a string object. There's my variable S2 pointing at another string object. Then this is asking, is S1 shorter than S2? And the answer was true. Okay, so I can ask interesting questions. Even though this thing is about numbers and strings are strings, you know, strings have length, so I can ask for the length of a string and get a number. And this could be the length of a string, and I get another number. So I can use my thing about numbers to ask questions about the lengths of strings. Okay. Now, all these in the table are about numbers. Is that number equal to that number? Is that number not equal to that number? So these are only about numbers. You can't, like, you can't ask, is a string equal to a string? You can, but you don't get it. It's actually wrong to do it. Java won't stop you from doing that, but it's actually, in a little while, we'll see what's wrong with it. But I can do this. They really shouldn't let me do this, but I can. I can say, is S1 equal to S2? Okay. You might think that's asking, is this string equal to this string? Okay. Now it printed false, but there's kind of a problem there. Let me try something. Oh, true. See, it pointed. Notice how it even though I said hello, hello. Notice how they got pointed to the same string.
Professor, the
Yeah.
the true is implying to the length of the variables.
Oh, I haven't. Well, it's going to print true here too. See, yeah, yeah. I hadn't gone enough steps yet. See, notice how Java actually made those two variables point to the same string. And that's why this is true. Okay, so they actually pointed at the same string. Okay, but in general, this is a bad way to ask if two strings are equal, because you can make it so that I have two hellos out here. It's a little bit tricky to do it, but you can create two hellos out here, and then you could have S1 point to one hello and S2 point to the other hello, and then they're no longer equal because they point to different strings. This is really asking, not are the strings the same letters, but are the strings actually literally the exact same string? Do the two arrows point to the same string? Okay. I'm not sure. I'm not sure if I can trick this thing into giving me two strings. Yeah, it still thinks yeah, it's still pointing to the same string. Well, and this one is still that same string. Yeah, I can't remember how to trick it into giving me two hellos, but it's possible to get two hellos, and then this thing is not doing the right thing. It's not comparing the letters in the string. It's comparing whether they are really the exact same string object. So this asks if they're the same object, not if they hold the same data in them. So for example, this wouldn't work with turtles. That's another example. If you have two turtles that in every way looked alike, but they were actually two different turtle objects, but they in every way looked alike, if you said T1 equal T2, you'd get false, because if they're different turtles, they're not the same turtle. Okay, so over here, this should only really be used with numbers, but Java doesn't force you to do that. Java lets you use it with objects, but it really shouldn't, because you get answers that you can get answers that are misleading. If you don't understand what's going on, you can get answers that are misleading. It would be better if Java did not let you ask this about objects. You can't do this. Now, it won't let you do that with objects. See? That only works with numbers, okay? The less than symbol's unexpected, okay? Or if I do that by itself. Now you might think, is this come before this in alphabetical order? That would make sense. Is S1 in front of S2 in alphabetical order? And we want to be able to ask that question, but we have to use something different to ask it. See, this operator can't be used on strings. So over here, all of these can only be used on numbers. These two can be used on numbers or objects, but they shouldn't be. These two here can be used on an object, but they should not be. And this one too, it can be used with objects, but it shouldn't be. Okay, these can only be used with numbers. All right, so we have a way of asking questions. Now, we don't really just want to, like did here, print out trues and falses. We really want to use these questions in a useful way. So that's the next topic, the if-else statement. Okay. The if-else statement lets you use the answer to your question. So let me just do an example over here. Instead of just asking this question, let me do it this way. If, here's my question, is S1 shorter than S2? Now, what I really want to do is use that answer. So I ask the question in an if statement, and the answer is going to be either true or false. And then below the if statement, I put what I want to do if the answer is true. So I'm going to print the I'm going to print the shorter string. There's two strings, S1 and S2, and I want to print whichever one is shorter. So if S1.length is less than S2.length is true, S1 is the shorter of them. Now here's the interesting thing. Then I can put the word else here. The word else here is what I would do if this is false. If this is true, do this. Otherwise, else, most languages use the word else. A few languages actually put the word otherwise here. There are a few programming languages that use the word if otherwise. Most use the word else here. Else, I want to print, well, I still want to print the shorter string. But if this is false, that S1 is shorter than S2, that means that it's S2 that's the shorter string. So I can do an interesting calculation here. I can print whichever string is shorter. So no matter what you do up here, no matter what two strings I put up here, now here I know which one's shorter. I know S1's shorter, but I want this code to work no matter what somebody does to change those strings. Okay, so like right now, let's watch how this works. Now we know that, well, let's see. So line 7 printed out this true. S1 is shorter than S2. Now we're here at this question. We know that this thing's going to say true. So what's going to happen is we're going to go to line 10 and then skip out and be done. Okay. So what this is we're going to either do this line of code or do this line of code. If this thing's true, we're going to do this line of code. If this thing is false, we're going to do this other line of code. So we have to skip one of those. We do one and skip one. Like right now, we're going to do 10 and skip 12. So do 10 and skip over 12. Okay. Now, if I go back over here, I could make this hello, hello. Okay. Now, S2 is the shorter of them. This code will still work down here. It's going to always print the shorter of the two strings. So notice that we now know that S1.length less than or equal to S2 is false. Okay, so we know that what's in here is false because we just computed it and printed it out. But here's what we really want to use it. Okay, we want to know, is S1 shorter than S2? We know that's false. So we skip over 10 and go into 12. We also skip over 11. You don't do line 11. It's just there to separate this part from this part. So you actually never do line 11. You either do 10 or 12. Okay. Now we're going to skip from 9 to 12. And we're going to print out the shorter string, and then we're done. Okay. So this is sometimes we call this an if statement or a conditional statement. It's often called a conditional statement. That's why this is called conditionals and logic. Okay. Everybody's got their own terminology for these. So if some people call them if statements, some people call them branching statements, some people call them conditional statements. They call them branching statements because your program comes down here and can take one or the other branch. And we'll see in a minute, we can make this branch as complicated as we want. We don't just have to have one line of code there. We can actually have 1,000 lines of code there. We can have another 1,000 lines of code there. So essentially, this is letting us take a branch, a two-forked branch in our code. If this is true, we take that branch of code. If this is false, we take that branch of code. So this is sometimes called a branching statement. So an if statement, condition. Okay, this book over here calls them if statements. Okay, so they refer to them as if statements. Here he refers to them as conditionals in the name of the title of the chapter. He calls them conditionals, but then here he also calls them if-else statements. Okay, so people have different names, and notice that it uses the word branches because there are people who call them branching statements because it allows you to branch from one place to the other. Okay, all right. Now, notice that I'm using this relational operator which works on numbers, but I'm really asking questions about strings. So this is where things can get real useful. You know, because I can call a method on a string and get the length of the string as an answer, I can compare the length of that string with the length of that string. Okay, and I can ask other kinds of questions about strings too. Okay, like here's another question I might ask about a string. If, okay, does anybody see what that question's asking? How would you explain to somebody not in Java? It's asking, is s1.char at 0 equal to s2.char at 0? Okay, that's what it's asking. But what is it really? You know, if I ask you what code is doing, don't say, oh, what it's doing is it's saying s1.char at 0 equals s2.char at 0. You know, that's not what it's doing. In words, how would you tell somebody what that's asking?
It's asking if the first character of S1 is the same as the first character of S2.
Yeah, do they begin with the same first letter? Do they have the same first letter? Okay, so, and then I'm not sure what I would want to do in that case. Okay, if they have this, here's what I'll do. If they have the same first letter, I'll print that first letter. If they don't have the same first letter, I'll print both of the first letters. Okay, so the idea is that if I want to know the first letter in each of these words. If they have the same first letter, I just need to print it once. But if they have different first letters, I need to print both of them. So I'll print S1 dot char at 0 plus, put a little space between them, plus S2 dot char at 0. Okay, so this is kind of interesting. Okay, is there something I could do? I could say, do the two words begin with the same letter? If they do, print out that letter. But if they begin with different letters, print out the first letter in each one. Okay, so I'm able to ask a kind of interesting question. Do the words begin with the same letter? And depending on the answer, I can print out. What I don't want to do is repeat that same letter. So if there's the same letter at the beginning of both words, I print it once. Oh, and I need a semicolon there. But if they do actually have different letters, I'll print them separately. So, okay, here's this one. Now we know that those two do not have the same first letter. So this is a false condition. So we should jump down to line 17, and then we print out. We jump to line 17, and we print out the two letters. On the other hand, I can go back and change it just for the heck of it. Okay. Now they do actually begin with the same first letter. Now I know that the first letter of hello, hello is the same as the first letter of goodbye. And so now it will print out just the H because it's the same first letter. Okay, so I can ask, eventually programming is about learning how to ask interesting questions and make decisions in your code and get answers. So we're going to, right now we're just making up questions just to show you that you can do things like this. Eventually, when you solve problems, solving problems boils down to a lot about asking questions about your data and then doing different things depending on what your data looks like. So conditionals are they're half the code you write are if statements. As you'll see, is eventually when you write real programs, about half of them, if statements are used everywhere. You want to ask a question about your data and then do something depending on what the answers are. Okay. Now, right now I'm only doing one thing. When this is true, I'm just doing one thing. And when it's false, I'm just doing one thing. You don't actually have to do just one thing. You could do many things. Let me think of a good example. Oh, I can't think of offhand of a clever example. Let's see. Let me ask an interesting question here. Show you another interesting question. It's not going to use one of the relational operators. I'm going to say S1 dot, okay. Let's go to this homework assignment. And let's look at the methods from the string class. And let's see if we can play with one of them and do something a little bit interesting. Well, can't, let's see. Oh, get rid of that. Now shrink this a little bit. Notice that the return type of these, this is what kind of answer the method gives you. Now here is a Boolean answer. So that when you ask equals, you're asking if are two strings equal or not, and you get a Boolean answer, okay? And then there's an equals where you don't look at the case and you get a Boolean answer. Okay, let's use that real quick and see what we can do with that. Okay, we can ask s1 dot equals. Now we're not using one of these relational operators now. We're using a method in the string class. But these relational operators all answer with a true false. This method answers with a true false. So we can use it like one of these relational operators. So I'm going to ask s1 equals s2. Okay. Oops. And then I'm going to do something similar I did a minute ago. If they're equal, I'll print out one of them because there's no need to print out both of them because they're equal. Else, well, what if they're not equal? Then I should print out each one of them. So I want to do two things if they're not equal. I want to print S1 and I want to print S2. Okay, so I want to do one thing if they're equal and two things if they're not equal. Okay, now what I wrote is wrong. Okay, what I wrote is actually in a real subtle way wrong. Okay, here's how Java works. If this is true, you do one thing. And otherwise, if this is false, you do one thing. The rule in Java is you only do one thing. So this print S2 is actually not part of this else. It should be indented like that. It's not inside the else because I didn't place it inside the else. The rule in Java is there's only one line of code inside the else and only one line of code inside the if. Now, what if I want there to be two lines of code, I have to put them in braces. This is what I do to put two lines of code in the else. Now, with one line of code, I don't have to put the braces, but you should. And if you go back to the textbook we're using, if you look, you'll see that even when there's only one line, he puts the braces. And even when there's only one line, he puts the braces. That's the right way to do it. You're not required to do that. This is another one of those things where it's right to do it, but you're not required to do it. Just like indenting is a good thing. You should indent, but you're not required by Java to indent. Here, you're not required to put a brace when there's only one line of code. But when there's two or more lines of code, you're required to put the braces. Now, if I take out the braces, kind of interesting thing happens. Well, we can, let's do it the wrong way and see that really can tell that there's something wrong. Okay. Right now, let me make these the same. Okay. Okay, so string 1 is hello and string 2 is hello. So S1 equals S2. So I should print out only S1. So let me visualize this, and we'll see that it doesn't work the way, I look at my code and it looks right, but it's going to give me the wrong answer. So let me step down till I get to the interesting part. Okay, S1 equals S2. We know that that's true. They're the same string. So I'm going to go to line 21. All right. So I'm going to print out hello. But notice I didn't jump over the else part, but actually I did, because the else part's only line 23. So when I finished the if part, I jumped to line 24, which looked like it was part of the else part, but it's officially not, because I didn't use braces. Okay, so see, now I get hello printed again when I shouldn't have. Okay, notice how subtle this is. This looks good, but it's wrong. Now, to make this worse, If we were using the Python language, this would be correct to write. The Python language doesn't use braces, it uses indentation. So in the Python language, this is part of the else, but if you write it like this, then it's not part of the else. So in the Python language, it depends on where you put it. This makes it part of the else, that makes it not part of the else. In Java, the indentation actually doesn't matter. This is part of the else, and that's all. If I want them both to be part of the else, I need to put a brace here and a closing brace there. Now I've grouped them together. I need to group them. Java uses grouping, Python uses indentation. Okay, Java uses a grouping symbol, Python uses indentation. Now, this is actually bad because a lot of programmers go back and forth between the two languages, and it's not unusual for a programmer to be writing Java and forget they're in Java land and think they're in Python land. You type this, the compiler doesn't complain, okay? The compiler doesn't complain, and your code's not doing what you think it does. Unless you have very good tests, you may not notice that you have a bug in your code. This is why tests are so important, because you could write this because you're so used to Python. Now, let me show you something that's a little bit interesting. Suppose I'd make the same mistake here. Okay. This is going to get an error message. This did not get an error message, but this will get an error message. Watch. And the error message is very subtle. Why? Okay. Else without an if. Okay, notice it did not complain about this line. It complained about that line. Because here's how Java read this. There's no grouping here. So this line is part of the if. This line is actually out here, and it ends the if because it's not part of the, it's not grouped with the if, so it's really out here, and it ends the if. Now this else doesn't have an if, and that's what the complaint was. There was an else without an if. Okay, very subtle mistake. The indentation fooled me into thinking, well, the indentation looks good, but the error message is about this guy, not about the indentation. But it's because Java really put this one outside of the if statement, so it really put it over here. If this was Python, it would belong over there. And then Python would also complain about this, because Python would say this guy is inside here, this guy ends that. So what's this guy doing by himself over here? So Python would complain about this also. Okay. Now, when we did this one down here, there was no error message about this one because this ended the else and there was nothing, this ended the else and then this was after the else. It was really this. Okay. And there's nothing wrong with this if else. Now, this can get confusing as all get out. So the answer is always use braces. The right answer to Java programming is always use braces. Even when you don't have to use braces, you should always be using braces. So like in my lines up above, I was lazy and I didn't use the braces when I should have. I should have put a brace there and a brace there. I should have a brace there. Even though they're not required, I should have them there. Okay. I should put braces everywhere I need, everywhere I should put braces after the if and after the else. I should always have, even when I don't need them, even when there's only one line, I should put braces. If you don't like all these empty lines here, some people like to move the brace to there. Some people like to move the brace to there. In the long run, I don't think that's a good idea. I think the brace is better there because as code gets more complicated, it helps your eye to see those two matching braces. It helps your eye to see those two matching braces. As you get more and more programming, see how that one matches something way over here? It's just harder to find. When code gets very complicated, you see the closing brace and you want to know where the opening brace is if you use this style, the opening brace can be almost anywhere on the page, as opposed to just being straight up. Okay, see in here, the closing brace is straight up. The closing brace is straight up. That helps. I'm sorry, I should say the opening brace was straight up. The closing brace is straight down. The braces line up vertically. Okay.
I also believe on Dr. Java, it will highlight what the brace will cover.
Oh yeah, it makes it a little bit easier to find that closing brace because it highlights from here to here. Okay, like you're right, in Dr. Java, it would highlight all this in between, which helps. So that makes it, you can just see where the highlighting ends and you can find the opening brace. But you know, that's not all editors do it that way. And sometimes you're reading text in a book. You know, you'll see eventually you're not always reading, like a lot of times you read code on a web page or you read code in a book. So you don't have a program that does good highlighting available. So your code should be ready for anything. You know, and one of the things that as a programmer, you want to learn to write code that's ready for any situation for anybody to read. So saying, oh, I use Visual Studio, so it makes this stuff easy, isn't going to help people who don't use Visual Studio. It isn't going to help it when your code is published in a book or when your code is printed out and handed to your boss. So, you know, saying things like my IDE fixes that doesn't help when someone's not using the IDE. If your code's up on a website, if it's in a repository, if it's printed out on paper in a book. So we have good styles that I think help. Now, where did this style come from? This style actually came from the 60s and 70s when screens were very small and you did not want to waste lines of code on these. So this was meant to shorten the code. It was not meant to make things easier to read. It never made things easier to read. It was meant to make code shorter. But we now have 77-inch monitors. And if you want, you can put a monitor on your desk that'll show you 1,000 lines of code. You look how many lines of code I have here. You know, we don't care that much about saving vertical space. It's more important to write code that's easy to read. It's more so. All code written in the 60s, 70s, 80s, and 90s used this style. And starting a few years ago, a lot of people started moving to this style. There's been kind of a trend away from that other style to this style. It's a trend. Right now, probably 2/3 of the world I'd say about 2/3 of the world use this style right now, and about 1/3 use this style right now. But this style's growing because it gives you easier to read code, and you don't care that much about vertical space. We have big monitors these days. We have big monitors. We're not worried about vertical space, and this is way easier to read. When you're trying to digest thousands of lines of code that somebody else wrote, this just is one little thing to make it easier to read. Okay, all right. So you'll see the other style everywhere. And there's also another problem. JavaScript doesn't like this style. JavaScript kind of forces you to use this style. It's one of the big problems with JavaScript. JavaScript is not agnostic about how you write your code. It actually, it doesn't require, but it strongly prefers the braces to be like this. It strongly prefers braces like this, which is really a dumb thing. So, and that's a mistake, and it's a well-known mistake in the JavaScript language, but it's too late to fix that now. So the JavaScript language kind of pushes you to write code this way. And then Python said, this is all dumb. This braces stuff is really foolish. So the Python people said, just use indentation. No braces, indent. Way cleaner code, much less noise on the screen, much easier to read. And I think they're right. So a lot of people don't like it, but I think it's a good idea. Much less noise on the screen, and you clearly have, you have one rule, indent. Instead of having weird rules like, well, you can have braces or not have braces, you can put the braces there or you can put the braces there. Instead of having a whole bunch of rules and a whole bunch of cases and a whole bunch of different ways of doing things, Python has one way, indent, which is good. To have one good, clean way is better. Okay, So that's one advantage that Python has. Okay, so I use this style, braces winding up vertically. And I almost always put the braces in, even when there's just one line here. Even when there's only one line here, I tend to put the braces in. Okay, all right, all right. So notice that we can do a, okay, we're here, we were doing a test that used a method. Okay, now, whoops. Are they the same word now? Let's ask Java. Does Java think they're equal now? Notice that there are two different strings, but they have the same letters in them. Well, so let's see what Java is going to say. Does S1 equal S2? It jumped down here to the false part. Okay, so it thought that it didn't think they're correct. Now, if we go over here, there's an interesting equal. Equals ignore case. It's not unusual for you to want to know if two words are the same, but they just differ in capitalization. So you can go down here and say equal ignores case. So that's an interesting method that they give you. Okay, you can ignore. See, I misspelled it. Let's see, ignore case. Okay, they let you ask, are they equal? But don't worry about how the upper and lowercase letters are. Okay, so now I'm going to test these guys to see if they're equal by ignoring case. And now S1 equals ignore case S2. Well, they only differ by the capital H. So it's going to print out S1. Okay, it prints out one of them. But as far as I'm concerned, that's good enough because they were the same except for capitalization. Okay, so whenever there's a method over here that gives you back a Boolean, you can use it in an if statement. Okay, see, some of these give you back a string, some of these give you back a number, and some of these give you back a Boolean. They tell you whether these things are equal or not. Okay. Now, let me look at the longer list of methods. That was the short list, I think. Oh, there was oh, okay, it's not here. Ah, yeah, here's one that's in this list that's not in the other list. Okay. Oops. Starts with. Okay. Starts with whether or not the string starts with some text and it returns true or false. So this is one of the Boolean methods. You can ask, does my string starts with? You can also ask, does it end with? Now that's not in this table over here. So that's one of the reasons why I gave you these two tables. This was one method that's kind of useful, starts with, that isn't in this table over here. So I can go over here and I can ask a question like, does S1 starts with, and then I can just say, well, actually, here's one thing I could do. I could ask, does S1 starts with S2? This would be a weird way of saying, is S2 the beginning of S1? So if I went up here and did something like, notice that it would now be true that S1 is the beginning of S2. S1 is the beginning of S2. So if I ask down here, does S2 starts with S1? The answer will be true. Okay. So I can add, let's just play it with, just look. Okay. Notice that there are two different strings, but the first 5 letters of this one is the same as the first 5 letters of this one. So this one starts with the same thing that's in that. Okay. So if I get down here, now I'm asking, is it true that S2 starts with the letters that are the same as what's in S1. Is S1 the beginning of S2? And we know that from here it is, so I'm true. Okay. All right. So notice I can ask real interesting questions. If a method returns a Boolean, I can use that method in an if statement to ask a question. And over here, the only Boolean ones are equals and equals ignore case. But in this other table, there's also this other Boolean starts with. Okay. You can ask if this one string starts with another string. Okay. And ends with. So that's another Boolean. It returns true. See, in this example, they assume that S is HELLO. Then they ask S ends with LLO. Well, that's true. Here they said S is HELLO. And they asked S starts with HI, and the answer is false. HELLO doesn't start with HI. So they're telling you that this one returns true or false, and this one returns true or false. Okay. All the other ones in here are also over here. So the only ones in this table that aren't in this other table are starts with and ends with. Okay. So when a method returns a Boolean, you can use that method like you would use one of these relational operators. Because what these relational operators really do for us is they return a true or a false. Okay. So what we're really interested in are things that return true or false, things that are Boolean. Okay. So that's either going to be these operators or methods like this that return true or false. Okay. I can't remember if the turtle had any Boolean methods. I don't think the turtle did. It's hard to imagine what you would ask a turtle where the turtle would answer yes or no, true or false. You can ask a turtle, are you at location 00? You might want to ask a turtle, are you at a certain location? I can't remember if that's in the turtle or not. I don't remember if you can ask a turtle, are you at a certain location or not? But that might be something you could put a method in a turtle, are you at? You can call it, are you at? Or something like that. And you can ask the turtle, you give it an X and a Y coordinate, and you would be asking the turtle, are you at this X, Y coordinate? Okay. So, you can put Boolean methods in any object you want. And in this case, we're using the methods that are given to us. Somebody else wrote all the code for string objects, and somebody else wrote all the code for turtle objects. So we'd have to ask them if they put a Boolean method in their turtle. Here we see that they did put some Boolean methods in a string. Okay. All right. Now, what else do we want to know? So far, we've talked about, whoops. Okay. We've got the idea of a Boolean, something that's true or false. Something simple, something that's true or false. We take things that are true or false and we put them in an if statement. If they're true, we do the first branch of the if statement. If this thing is false, we do the second branch of the if statement. Okay? We can put anything in here that answers true or false. We can put anything in there that's true or false. Usually, especially in the beginning, it's the relational operators are the most common. Do comparisons with numbers, less than, greater than, equal, not equal to, greater, not, less than or equal to. So a lot of this simple stuff just uses comparison of numbers. But then you could call methods on objects and get information about an object, which is a number, and compare it to, So I'm using a number comparison on strings by asking the string to give me its length. Or then I could switch to doing Boolean operations on the string. I can ask this string a Boolean question. That's where things start getting real interesting. If your objects have methods in them that can answer Boolean, then you can put those questions in if statements. Okay, now there's another thing that's worth pointing out. You don't actually have to have the else part in an if statement. Java is perfectly happy if you just, and not all languages are like, this is another thing that is not true for all languages. Java lets you just ask, let's see, well, what should I ask? Let me go. Okay, I'm just gonna ask a dumb question. Is S1 this? And I'm gonna print out something. Okay, I'll go ahead and put my brace. Okay, no else. That's perfectly okay. Okay, you don't have to have an else with an if. Okay, sometimes that's a little bit useful. Some programming languages don't even allow this. They don't have a rule that an if can be without an else. Some languages have a rule that every if has to have an else along with it. But Java and JavaScript and C and C++, those languages don't have that rule. They'll let you have an if by itself. Okay, and whoops. Oh, I didn't want that semicolon there. Okay. Now, the rule now is if this is true, you do what's inside here. If this is false, you just completely jump over it. Now, in our case, that's false, so we just jump over. See, we just went from line 38 to the end of the program. So if you have an if statement with no else, and this is false, you just jump over the inside. On the other hand, if you have an if that without an else and it's true, then you do what's inside. Okay, so if you have an if and what's inside here is true, then you'll do what's inside here. If the Boolean is true, you do the clause that's in here, and then you leave. Okay, so you can have an if by itself without an else. There's no such thing as an else by itself. An else by itself doesn't. That's why up here, if we put 2 lines in here without the braces, remember that else became a problem because if 2 lines without braces up here really meant that the else was by itself. If we go back and make a mistake up here, just remember, if we do something funny like this, it looks to us like it looks fine. That looks indented okay, but Java is going to complain else without if. See, it did, because really what's happening there is without the braces, this is over here. That makes this an if by itself with no else clause. So that's the whole thing. It's 9 and 10 is one unit of Java. 11 is its own line. And then there's a stray else all by itself, which is wrong. Okay. If this was Python, this would also be a stray else all by itself because this would end that if statement. Okay. In Python, this would be part of the if statement, so the else would be okay, but not in Java. Okay, so then I have to lump them together by putting braces. Okay, so you have to notice how tricky. You have to really think hard when you get error messages in programming languages like this. You have to go through all the things we've talked about and think hard about what we've said because there's so many little things that can cause an error. And the best way to prevent errors is to follow the rules. Like keep remembering, always use braces, always indent. Always use braces, always indent will solve a lot of problems for you. When people send me their questions, a lot of times you're writing your code, and I notice that as you're writing your code, a lot of you don't do the indentation. That's bad. Don't do the indentation at the end when you're about to turn your homework in. Do the indentation every time you type a line because you'll only mix yourself up if you don't keep track of the indentation. There's a lot of times when students send me questions and the answer is you've got your code mixed up because you didn't pay attention to the indentation. As you were writing code, you weren't keeping up with the indentation, keeping it nice, and you get mixed up. every time you type a line of code, make sure it's indented properly. As you're typing it, don't wait till later to do the indentation. Follow simple rules. Always put in braces, always keep things indented. That'll prevent a lot of goofy errors that are hard to track down. Always indent, always use braces. Okay, all right, what else? Now over here, oh, we've actually done everything. Okay, we've done all of these. Trying to think if there's anything we didn't do yet. No, okay, we've covered, okay, we've talked about every idea that's in this reading assignment. Okay, so we've talked about all the ideas that are in this reading assignment here. Okay, but let's see. So got a couple minutes left. Anybody got a question about what we've been talking about? Because there's a lot of information here. There's a lot of stuff here. Anybody got any question?
I have a question about previous homeworks.
Yeah.
Did you get the chance to grade them? Maybe.
Oh, I'm working on them. There's a lot of students in the class. It takes a little while to do the grading. So I'm hoping that the scores will be up there in a day or two.
Okay, perfect. Thank you.
Yeah, we're working on doing the grading right now. So hopefully the answers will be up in a day or two. Yeah, and you'll get your answers in Brightspace. So you'll see them in Brightspace when they're graded. You'll see that in Brightspace.
All right.
And then when you get your scores and you get your graded, then if you have questions, you can send me an email. So you'll see the scores in Brightspace, and we're still learning how to use Brightspace. I think we can give you comments. That's one of the things I'm hoping that we can give you is like comments on Brightspace too. I don't think we have a way of handing back your code with comments. So the comments will probably be restricted to being in Brightspace, and we're trying to figure out a good way to do this. What we want to do is give you back your score and also give you back a little bit of information about it too. But when you get your score, if you have questions, please, write about that. Send an email. Okay. Anybody else got other questions about what we talked about or about homework assignments?
Yeah, could you go over like homework 3? I couldn't get like all the inputs to give the output, you know what I mean?
I'm not sure what you mean.
I just
Could you use these test cases?
yeah, I could. Not all of them would do what I need them to do though.
Oh, that means your program's not working right.
Right.
Did it work sometimes and not other times?
It worked with it works all the time with some of them, but not with all of them.
Okay, which one didn't it work with?
It only worked for the Java one and then the ABC one.
Okay,
But
it
the
worked
rest
for
of
this
them,
one. Java is the language,
yeah,
and this one.
yeah.
Okay, so you have to think so you have to think about what could that mean about your code. It worked on a simple case like this and this. So like, what did it do wrong here? Okay, it must have done something with this. What did it do?
So what I was doing was, you told me to give a variable for.
No, wait, stop. What did your code produce when you gave it this input?
It gave a space in front of line, and then it didn't capitalize line.
Okay, that's because you didn't remove that extra space after you got rid of the word this. Okay, so what you have to do is, after you remove the word this, you have to ask, is there extra spaces there? Okay. Now, there's a method in here to get rid of extra spaces. So look at the methods in the string class. There's, at the bottom here, there's one called trim. Returns a new string having the same characters as the string, but with leading spaces and trailing spaces removed. Okay? So after you get rid of that, and you're left with this, how do you get rid of that stuff in the front?
So you just do the trim.
Yes, trim it,
But
which is a good name. That'll give you this.
Right.
Now you can get
then
the first letter.
Okay.
Yeah. So that
So like,
Mhm.
I'm kind of lost on like how I'm supposed to do that all. Is this gonna be on like different lines then?
Yes. Yeah. Just do each step is its own line of code. So create a new variable to hold what the result of calling trim. So you can end up you have lots of variables where each variable holds one little step of the process of solving the problem. So
So
every
is this gonna be like one big if statement?
no,
for
there's no
each
if
of these?
statement. No. You just you've got this as your input string, right? Right? So you want
Okay.
to peel off this first word and put it in one variable, and then peel off the rest and put it in a second variable. So I got three variables. One variable holds the original string, one variable holds this part, and one variable holds that part. Now you call trim on the part that holds this part, and you store the result in another variable that holds this. That's your fourth variable. Now, see, you just keep creating new variables with each step. Now,
How do you
Have you tried using like index of certain character and like just put space in it?
yeah, see, like first of all, how do you get this part here by itself? How do you get the first word by itself?
what I was doing was I was doing a substring
Yeah, substring with from 0 to what?
to like 4.
No, because what if I put onomatopoeia as the first word here?
Right. See, that was the issue. Like it wouldn't.
You
If I did from
find
0
the
to 4, then the ABC
Okay.
one wouldn't work.
Right.
So
So you need to
use
use
like
the index of method to find the index of the first space.
index of the first space.
Yeah, see, index of the first space will always be at the end of the first word. So if I have a sentence that has how do you find the end of that very long word? You find the first space. That first space is at the end of the very first word. And it'll find, if the first word is A, or if the first word is okay. How do I find the end of that very long word? Well, it's easy. The end of that very long word is the index of space. The first word's
Okay.
always ended by a space. So if you find the index of space, you find the end of the very first word. So you need
So like, so how would you do this without an if statement though?
well,
Because like they're all gonna have different indexes.
but you just need to know what that number is. See, that number is say 15. Then you do a
Okay.
substring. You store it in a variable. So then you would need a variable that would hold that index. So, maybe like this case, the answer would be 5. The index of the first space is 4. The index of the first space is 4. Here, the index of the first space is 1. Here,
Right.
the index of the first space is something like 15. I put that in a variable. I don't need an if statement. I just need to remember that thing. So on this string here, I call index of space, and I find the index of that letter there, the first space. Then I take a substring from 0 to that value that I store in a variable, that peels off the first word. Okay?
Hmm.
Use variables. Every time you compute something, store it in a variable so you can use it. So you find the index of the first space, store it in a variable, store it in a variable, store it in a variable. Then you don't need an if statement because there's nothing to decide. You know the index of the first space. Just because it's different in one string than another doesn't mean you have to make a decision. So you're not deciding anything. You're using whatever that number is. Whatever that number is, from 0 to that number is the first word. From 0 to that number is the first word. From 0 to that
So-
number is the first word.
So when you're making that substring for that, oh, never mind.
Mhm.
Okay, so then like, I don't even know.
What you have to do is you have to imagine how you would do this in your head and then make those steps of code. In your head, you'd have to say, I need to know where that space is so I can find that word up to that space. Then I need to chop off the rest of the stuff. After you've chopped off the rest, you have to say, well, I need to get rid of this space that's extra at the beginning here. I need to get rid of this extra space here. So I trim it. Okay. Then I would need to find this first letter here as a substring because I need to peel it off so I can capitalize it. Then I need everything after that first letter. Then you reassemble everything. There's this piece capitalized. There's this piece after it. And then there was this thing here, it gets tacked on to the end. So you'll break it apart, then reassemble it. Well, we actually run out of time. We run over. If you still got questions, either come to the office hour or send me an email. Actually, the office hour starts in a few minutes. So if you want, you can just ask questions during your office hour. But the idea is that you have to step your way through what the code needs to do. Think of it in your mind and then try to turn each step into one line of code. It's pretty much each step of what you would do with this thing turns into one line of code. And use lots of variables. Store things in variables so that you can reuse them. Okay, well, I'm going to end now because we've gone over. So I'm going to go ahead and stop sharing, and then we'll meet again on Monday. And if you have any questions, come to office hours or send me email. Okay, so see you on Monday. Bye-bye.